Hello everyone, this is RaySpace, and I'm here to talk about SpaceX's Starship, their spacecraft that is meant to bring crew all the way to Mars. And there are many problems with Starship at the moment, but I feel like there was one big mistake made early on in the design of Starship, and that is in terms of its diameter. In fact, SpaceX had the right idea first, as I will soon show. Maybe people remember it, maybe people don't, but the original system was called the Interplanetary Transport System, ITS, and it was 12 meters in diameter. And if we take a look at SpaceX's plans for Starship, and there's a SpaceX graphic here, Starship 3 is getting rather longish, you might notice here. So the original version is here on the left, and it didn't really have a payload to orbit as such. Starship 2 is a little bit heavier with more prop load, and then Starship 3 adds 3 engines, and then also supposedly in this graphic had 200 tons. But if we take a look at Elon's own tweet from March 22nd, we see that he now says it will yield 100 tons. So there's the version 3 Starship that's yielding 100 tons. Well, that's not great, is it? I mean, here they said 200 tons just a little while ago, and it went to 100 tons. What's the deal? Well, increasing dry mass. The problem is Starship has to do many different things. It has to get to orbit around Earth, be reusable, then eventually they have to add mass so that it can survive the trip to Mars with some propellant. So they have to make sure that the tanks don't have too much boil off. They have to add the propellant transfer capability so that it can get refueled. And there's probably other things that has to be added to its dry mass in order to make that work. We're still on the getting to orbit and coming back safely part as far as adding dry mass. And this was one of the lessons of the Space Shuttle. One of the lessons of the Space Shuttle was that if you have a vehicle that's meant to do too many different things, you're going to add a lot of dry mass to it, like the Space Shuttle's big wings for cross range and stuff like that. And then it can't carry much of a load. So we have this problem with Starship, and that brings me to ITS. This is also a SpaceX graphic, and the ITS was a bigger system in terms of diameter. It was 12 meters, as you can see here, 12 meters. The propellant mass was supposed to be 6,700 tons, and the first stage would have had 42 Raptor engines. Now, that saves us a little bit in terms of one of the problems with the engine design is that they keep trying to push the chamber pressure harder and harder, and that might hurt eventually the ability of the engines to relight after a long trip to Mars, 9 months to Mars, and then staying on Mars for more than a year and a half, 3 years altogether. They have to light the engines in order to be able to land back on Earth. So that's a lot to ask of engines, especially when you're pushing their performance. If you have more diameter at the bottom of the rocket, you can just add more engines to get more thrust instead of trying to push the chamber pressure. And that's actually what we see them doing here right from the start. This was the original idea. Now, their dry mass, well, actually their dry mass is pretty accurate for the booster, and that's about what Super Heavy is. So that's not too bad as far as an estimate is concerned. Why do you want more diameter? I know you're asking. Well, the reason you want more diameter is because the surface area of the vessel is going to scale by the square, but the volume scales by the cube. So if you increase the diameter by 33%, you can get 77% more volume. And so a little increase in diameter gives you a lot more fuel capacity, as long as you can make the tank strong enough. Now, originally they were going to use carbon composites, and of course carbon composites are very light while maintaining strength, but then so is steel. Well, no, steel isn't very light, it just maintains strength. Well, that's a different problem altogether. But at least they would be able to build it 12 meters while maintaining strength, okay? But yeah, steel, let's set that aside for now. The steel topic is a whole other topic. But you'll note that the actual spaceship is much more stout. It is not as long as this version. which is getting a little bit freakishly long. And you worry about its aerodynamics and whether those fins are really going to do their finny things. So that is a little bit of a lifesaver on this one. Also gives you more room to fit the 9 engines that they eventually want to need. Now, their estimates for this interplanetary spaceship were very optimistic, with the ship and tanker masses there. And also note the typically optimistic cargo capacity, 300 tons. But still, if you start off with 300 tons of capacity and then you add dry mass, that gives you a lot more room to work with. Note the propellant mass right from the start for this thing. The ship is 1,950 tons, and the tanker version would carry extra fuel, but 1,950 tons, let's say, for the ship, and then the booster 6,700 tons. So this is much bigger. But here we're going with 4,050 tons of prop here and 2,300 tons of prop for Starship version 3 there. So we're getting more prop in Starship, the actual ship, 2,300, than they were planning on getting in this 12-meter version. Right? This is 1,950. This long thing is now 2,300. So maybe it should have been 12 meters in the first place. And so the conclusion, they were right. They were right in the first place. They're not right now. This is Kartoffelkuchen's old ITS. It's not particularly refined because I think Kartoffelkuchen of the KK Launchers pack realized that they would be changing things quite a lot. So it's not super detailed, but it's nice. And maybe we should bring it back. Maybe this is what should have, 9 engines at the bottom. And so I'm tempted to make a newer model of it, a shinier steel model, let's say. And also, I'd probably just modify Pekka's Starship and Super Heavy, or I don't know if Pekka would be willing to do it and make a 12-meter version himself. But that's the idea. Maybe we should have a 12-meter Starship, and that would work better and not look so freakishly long, and also allow for more room for an increase in dry mass, because they're still on the making it survive Earth thing, and they're going to need to make the getting to Mars part. And if they're still 9 meters, that doesn't give them much room to do that. I know it's a little bit late to change the design now, but we're in Kerbal Space Program, so I get to do that. They don't get to do that. But well, that's their problem, isn't it? They should have stuck with their original design and gone with it. But no, it was too much cost to develop that, wasn't it? Well, shucks. Here we are. So right now, version 3 of Starship can only get 100 tons to orbit, according to Elon's tweet. And that's going to be a lot of refueling trips, because its fuel mass right now is 2,300 tons. So tell me what you think. Do we bring back ITS? It probably would increase the payload capacity and make it much easier for me to actually fit payloads into it, because a lot of payloads tend to scrape the sides of Starship. What do you think? Am I right or am I wrong? Tell me in the comments below. With that, thank you for watching, and I'll see you next time.